Hi, I am Mohammad Nadeem from Exam Help Web. In this video, I am going to describe Kirchhoff's circuit laws followed by some examples to show you how to use Kirchhoff's laws in order to solve complex circuits. It is relatively easy to find equivalent resistance while two or more resistors are connected in series, parallel, or combination of both. These circuits follow Ohm's laws. There are certain complex cases where it is not easy to use Ohm's law at first. There are certain rules generally called Kirchhoff's circuit laws. The first law deals with the current flowing through a closed circuit is called Kirchhoff's current law, while the second law deals with the voltage sources present in a closed circuit called Kirchhoff's voltage law. Kirchhoff's first law states that sum of all the currents meeting at a point must be equal to 0. Sum of all the currents meeting at a point must be 0. It is a convention that currents flowing towards a point is taken as positive and currents flowing away from a point is taken as negative. Considering this convention, let's look at the example where four currents are meeting at point A. In this case, current I1 and I2 are moving towards point A, while current I3 and I4 are moving away from the point A. Therefore, I1 and I2 will be considered as positive. I3 and I4 are considered as negative. So therefore, I1 taken as positive, I2 taken as positive, and according to Kirchhoff's current law, this is which is considered negative here. Likewise, I4 is also considered negative here, must be equal to 0. Or we can also write this equation as I1 plus I2 is equals to I3 plus I4. We can say that the currents flowing towards a point is equal to the currents flowing away from the point. Voltage law states that the sum of all the voltage changes in a closed circuit must be equal to 0. Let's take this simple example of Kirchhoff's circuit's law case here. In this circuit, we have three resistors and a supply of 24 volt. Resistor R1 is 3 ohm, resistor 2 is 4 ohm, and resistor 3 is 12 ohm. In order to start solving this complex circuit, we have to consider few rules which are basic before we start. The first is find out the nodes. Node is a place where two or more branches or sources are meeting. Okay, let's say this is node 1. This is again another point where two resistors are meeting. Let's say N2. The second step is identify the current and its direction. Let's say this is, since this is positive, negative, so current flowing towards from positive to negative. So this is I1. And at this point, the current has two paths to flow, this one and this one. Let's assume current flowing in this direction is I2 and current flowing in this direction is I3. And this is the positive end, this is negative end. Again, this is positive, this is negative, this one positive and this one negative. So we have done the second step. Now the third step is to find out the loop. Here we have two loops and the loop generally starts from positive clockwise. Let's say this is loop 1 and this is loop 2. We will now apply KCL on node 1. The current moving towards node 1 is I1, therefore it is taken as positive. The current I2 is moving away from node 1 and current 3 also moving away from node N1. Okay. We can also write this I1 is equals to I1 plus I2 plus I3. So this is one of our required equation. Now apply KCL at N2. Here I2 is coming towards the node N2. I3 is also coming towards the node, whereas I1 is moving away from the node, means negative I1 is equals to 0. So this is exactly the same equation again. I1 is equals to I2 plus I3, exactly the same equation. Now we will apply Kirchhoffs voltage law for loop 1. Okay. Before we start creating equation for loop 1, let's consider some important points. Those will be helpful in writing this equation. We generally start writing equation from we'll take any starting point. For example, I1 will move from here to here and then we'll come back towards this. So while moving in loop, we'll consider the sign. If the current is moving from positive to negative, it means there is voltage drop. And if the current is moving from negative to positive, it means there is increase in voltage. So this is an important consideration for equation writing. We'll consider Ohm's law, V is equals to, in order to find voltage here. So let's take I1 as a starting point. Here I is moving from positive to negative, so therefore it will be considered as negative 3I1, and now the current is again moving from positive to negative, so this is again negative 4I2, and now this is moving from negative to positive, so therefore it will be considered as positive 24 is equals to 0. Or we can rewrite this 24 is equals to 3I1 plus 4I2. Okay, now we will apply Kirchhoff's voltage law on loop 2. 4I2 minus 12I3 is equals to 0. This is our equation 2 and this is equation 3. Now we will place the value of I1 in equation 2. So 24 is equals to 3 I2 plus I3 plus 4I2. Let's simplify this. 3I2 plus 3I3 plus 4I2. That makes 7I2 plus 3I3. So this is our equation 4. Let's divide equation 3 by 4 so that we can eliminate either I2 or I3. Four I2 minus 12I3 is equals to 0 divided by 4 is equals to I2 minus 3I3 is equals to 0. So this is our equation 5. Or we can also rewrite this. 0 equals to I2 minus 3I3. And now we can add up 4 and 6. So 24 is equals to 7I2 plus 3I3, and let's add I2 minus 3I3. So we have 24 is equals to 8I2 and I2 is equals to 3 ampere. Now we can place this I2 in equation 6 to find out the value of I3. 0 equals to, in place of I3 now we can write 3 minus 3 I3. So 3 is equals to 3 I3. I3 is equals to 1 ampere. And we also know I1 is equals to I2 plus I3. We have I2 of 3 ampere and I3 we have 1 ampere. So I1 is 4 ampere. So with this, now we have all the three currents. Here I1 is 4 ampere, I2 is 3 ampere and I3 is 1 ampere. So this makes very sense that 4 ampere splits into 3 ampere and 1 ampere. So this verifies that the values of I1, I2 and I3 calculated are meaningful. Let's take another example of Kirchhoff's circuit law. This circuit has two source of voltages and three resistors. Let's start applying the basic rules. Find out the node. This is node 1 and this is node 2, and we know this is negative, this is positive, and let's also mention the polarities of resistance: negative, positive, negative, positive. Wait, this must be, since this is positive, so this must be positive and this one is negative. So it means that the direction of the current I1 is, this is I1, this is I2, and this is I3. And let's find out the direction of the loop. Loop 1, and here the direction of the loop is anti-clockwise. Let's apply Kirchhoff's current law for node 1. I1 plus I2 minus I3 is equals to 0, or I3 is equals to I1 plus I2. Let's look at node 2. So there is one current coming towards node N2, which is positive, and then the two currents are going in the opposite direction. So means I3 minus I2 minus I1 is equals to 0, or I3 is equals to I1 plus I2, same equation. So this is our equation 1. Let's apply Kirchhoff's voltage law at loop 1. Let's start from this side. This current is moving from positive to negative, so therefore minus 10 I1, and now this is again moving towards minus, so therefore minus 40 I3, and now moving from negative to positive, so this must be positive 10 is equals to 0, or we can also write this as 10 equals to 10 I1 plus 40 I3. Let's consider this as our equation 2. Now apply voltage law at loop 2. Let's start from here. So this is I2 is moving from positive to negative, means minus 20 I2, and then again from positive to negative, so minus 40 I3, and now moving from negative to positive, plus 20 is equals to 0, or we can write this 20 is equals to 20 I2 plus 40 I3, This is our equation 3. We know I3 is equals to I1 plus I2. We'll replace this value in equation 2. 10 is equals to 10 I1 plus 40 I1 plus I2. We can simplify it. 10 I1 plus 40 I1 plus 40 I2, or 10 equals to 50 I1 plus 40 I2. So this is our equation 4. We'll also place this in equation 3. 20 is equals to 20 I2 plus 40 I1 plus I2 is equals to 20 I2 plus 40 I1 plus 40 I2. 20 equals to 20 plus 40 is 60. 40 I1 plus 60 I2. This is our equation 5. Now we have two equations where we can eliminate either I2 or I1. Let's multiply equation 4. Multiply 4 by 3 and multiply 5 by 2. So we have 30 equals to 150 I1 plus 120 I2, and equation 5 is 40 is equals to 80 I1 plus 120 I2. Now we can subtract. So we have minus 10 is equals to 70 I1, and this cancels. So now this is I1 is equals to minus 10 upon 70, which is equals to minus 0.14 ampere. We'll place I1, value of I1 in equation 4, which is equation 4. 10 equals to 50 into minus 0.14 plus 40 I2. So 10 equals to minus 7 plus 40 I2, or 40 I2 is equals to 17, or I2 is equals to 17 over 40, which is equals to 425 ampere. Now now we can place the value of I1 and I2 to calculate I3. I3 is equals to I1 plus I2, which is minus 0.14 plus 0.425